My friends, welcome to this weekend special. Last week we did Model Mania 2008. Today I'm thinking 2009 looks like a good candidate for today's session. These models were developed by SolidWorks and this is part of a competition. So I'm not going into competition, but I'm practicing on these special projects. And today I want to work on this lever handle kind of thing. And this is really, it looks simple, but there are some real neat tricks in there. So here is phase one, where I'll be building this model and I'll try to build with the fillets. I learned some new tricks on how to do the fillets on FreeCAD. And then we will do FEM analysis on the phase two of this competition. So without further ado, let's get started on Model Mania 2009, and I'll start with calibrating the image. First of all, I want to see how far 125mm will go in the workspace we are. So we calibrated that, and I want to make it half transparent. And then I want to keep this image on, I'm going to say I'll start with this face. I'm taking that as a front face, so that would be XZ plane. And then I trace that image on the front side, right? And I will be using this one. So let's go ahead and transfer the center of the image to the center of the workspace by transforming it. So right click on the image and then transform it. I want to place it right where the center is. It would be easier actually to place it here. So there, that's where the axis cross was, and I say okay, and let's take the axis cross away from our view with pressing AC on the keyboard. All right, so first of all I want to work on this cylindrical hole first, and then this hole second. Then I will work on this base pad. Finally, I will be working on the spine. So it will be 4-part drawing, and I want to get these two holes, the cylindrical holes, taken care of real quick. And to do that, I will be drawing sketch on XZ plane. And the cylindrical hole, if it was a straight one, I would probably use the primitive, but now I'll have to use the sketch instead because it has a slope on the outer surface. And the height is given as 40, so we take care of that. This slope says 4 degrees with the vertical, so it would be 86 degrees with the horizontal. And then this is, so the inside diameter is 45, so this length would be 22.5. And this length we will get from the difference of these diameters, which is 15, right? So this length would be half of that. I'm going to go ahead and then actually make it a formula. So 60 minus 45 divided by 2. All right, so we got that sketch completed, and I'm going to rename that as, I'm going to say sketch right cylinder. I'm going to go ahead and revolve it against this vertical axis. So we had our center right there, so it would be the z-axis. Pretty simple. All right, so we got that hole taken care of. Pretty good. We can rename that and say right, and then let's forget about that. Now we want to work on this cylinder on the right side. Actually, it will be left. All right. Now I want to work on the right cylinder, so we will be drawing this sketch right here, and then we will have to revolve against this line. To do that, we'll have to actually draw another line here because the axis cross is not there. So what I can do real quick, I can relocate the image to match with this axis cross, so that way our revolving would be a bit easier. And then I'll relocate it back later on. The same thing, XZ plane, and then there will be a sketch. Revolve real quick against the Z axis. And so now go ahead and rename it as. Now we bring the previous one back. See, both of them are the same location. I want to keep this one where it is and relocate this one. So let's take the image back to its original position. So I want to keep this big cylinder up there and take this right cylinder down here. So we can see the vertical difference is 30. So in the z-axis it is minus 30 and horizontal difference is 125. So x it will be 125 there. Pretty simple. Now that we are done with these two cylinders, let's hide those by pressing space on the keyboard, and let's turn our focus into this base. Now there are two ways we can do the base. Now this base has a 4-degree inclination. So here we can see this is the cross section AA, and it says this spine has 8-degree inclination, but the base has a 4-degree inclination across. And we can, what we can do, we can build it from this XY plane and then cut it out, or we can just swift it. So let's go with the swift thing. So what I want to do, I want to draw this spine, the lower part. Maybe I want to draw the whole spine, although I won't be working on it right now, but I want to draw the whole spine thing. And I want to start from the center, although there is not anything in the middle. I want to start from there, and then we'll take care of it once we build the object. Real quick, I'll be building the outline of this spine, and I'm using polyline, and I'm hitting MMM on the keyboard to switch through between different modes. All right, let's fix those lines. This will be horizontal, and then this is 40 height. Now I want to keep them independent. I could take this as a reference from the cylinder that we just drew, but let's keep them independent so we can manipulate these values independently without worrying about another part. Okay, so here we have to apply a tangency, right? And then so the distance between these two, the vertical distance is 30. I want to fix that one first, and then the horizontal distance is 125. So we have our limits defined. Between these two, here it says this is 50. So I'm gonna go ahead and take a couple of construction geometry. Right, and let's make these two tangential to each other, and so will be these two. I think they're already tangent, so don't have to worry about that. So take these 2 points, and then distance is 50. We got that taken care of, and then the radius is 20. The radius is 20 here too, so I'm gonna go ahead and take all of these and make it equality. So we have to do this distance one more time right here, Let's go ahead and take care of that. So that fixes the lower part. The upper part, it doesn't have that lateral distance thing, but it has this normal distance between these two lines, and we can do that with this value, which says 25. And then one more thing, we'll have to make them parallel to each other. There. So that's a complete fully constrained sketch, and I'm going to go ahead and rename that as spine. Okay, lower part of this spine sketch will be the sweep path for our base, and for me to actually keep it good track of it, I'm going to go ahead and make that one line. So I'll go to the curves workbench. If you don't have curves installed on your laptop, you can do that from the add-on manager and search for curves. So there, curves workbench, and you can install it from there. And then you may have to restart if you install it. Restart the software, not the computer. All right, so what I want to do, I want to select all these lines that I want to make one specific line. So this is an optional step. I'm just doing it to make it easy for me. I'm going to say sweep path for lower base, or just sweep path. That will do. So what it does is it just gives me one line. It makes it easier for me to select it. So this part is optional. All right, so we have the sweep path, right? Now what I want to do, I want to create a cross section of this pad at the beginning and another one at the end, and then I want to do a quick sweep, and that will be on the other face, on the YZ plane, like on this, perpendicular to that sweep path. So I can do that easily, but I want to get those dimensions first. So on this one, the length of that pad would be 60 across, and the height is given as, okay, what is the height? I think it's 6. Yes, here. So 6. So it will be a rectangle. Well, it is a trapezoid. I'm going to go ahead and on the right side, right from here, so I can draw sketch. Back to sketcher, I want to draw a sketch on YZ plane, and there it's right where the begins the line, and it would be, so I want to start with a rectangle. This lower part is 60, and then I want to take these vertical constraints away, then make these two symmetric by the axis. So are these two. So this is a 4-degree inclination. So that is 90 divided 90 minus 4, so 86. And then the height is 6. So that's our first cross section. It is left cross section. And then the right one would be a similar thing, but the length is, instead of 60, the length would be 25, and everything else remains the same. So what I can do is I can take this one, copy and paste it, rename that as right cross section, then edit it to say this is 25, and that takes care of it. Now we'll have to relocate this to the end of this line, which is easy actually. So what I want to do is I want to select on that one, and on the map mode in the data tab, come here where it says deactivate, click on this more option button and then select this. At the end there is a vertex, the point, we want to select that one. So by default it would say translate origin, and that should take care of it. We just relocated that. Now we have two cross sections, one sweep path. We can go back to part workbench and select these two. So let's open up the sweep tools, and I'm selecting the left one and then the right one, and then say create solid, and then sweep path. I want to select this one where I created one line, and now I can just select it without worrying about the sequence of it, and hit done and OK. So we got our base pad. It looks a little funky here. I am okay with how it looks right now. It looks great. So that is our base pad. So we have the cylinders and base pad. The only thing left is the spine that has actually slopes built into it. If it was like a straight rectangular cross section, we can do a pad like this. So we can if it was a straight up construction, we could do a pad of like say 10 and then make it a symmetric, and that would be that easy. But our problem is a sloped wall, and that slope it varies. The angle stays same, but if it is, so how it says is up here, right, this has upper width is 6, and then the lower width will be varying because of the varying height, but the angle remains that 8 degrees. So that actually makes this extrude really unusual. So with all of that, let's go ahead and delete that extrude. What I want to do, I want to build two cross sections like we did for this sweep. We want to build two cross sections, one at here, one at there. Now here I want to take a moment and address the, well, not the shortcoming, but if you want to say that it's a shortcoming, I would not go against it. Given that FreeCAD is still developing and it's free, I don't want to use a strong word like a shortcoming. What I want to say is, see here we had two cross sections and then we build a quick sweep. I wish there was a way I could do that for this. I could build a cross section up here and another one up here and then do a quick sweep. But looking at this, see, this is two different outlines. So if we call them a rail, this sweep would require two rails. Now there is an option in curves workbench where we can do sweep on two rails right here. Sweep two rails, and this is really complicated and it didn't work out on this example. Really, it's more of a like a curve sweep. Here we have like right corners, all of that, so it doesn't work on here. I tried. So what I want to do is, I wish there was a way I would build two cross sections up here and here, and then we would just do sweep where we used one rail in the previously. We would be using two rails, upper and lower limiting part, and do the sweep. But FreeCAD doesn't have it yet. I have finger crossed it will be there soon. So we will go around and take a different approach to build this spine. Let's go ahead and build those cross section on this face, which is YZ plane. I want to draw a sketch on YZ plane. Right now I want to say reverse direction, because I want to do it from this side, right? And I don't want to do any referencing with any other sketch on this one as well, because I want to keep them independent. So this is 6, we took care of that, and I want to make that symmetric by the axis there, and then this is already there. I want to take out these 2 vertical constraints and then say this is an angle of 90 minus 8, so that's 82. Yes, and then I want to make it symmetric on this end as well. Finally, I want to say this has a height of 40. Cool, we got this cross section, right? I want to rename that as left cross section for spine. And on the right one, I want to do the same thing. So I'm going to go ahead and copy and paste it. Rename that as right. And all I have to do is change the width of it. So actually I won't be changing this one. It will be changed automatically. All I have to do is change the height of it. So it would be 20. So then we'll have to take this sketch, place it up there, down there, and so we can do that is select that and come to this map mode and select, okay, I'll have to hide this spine and bring the sweep path back. Okay, so deactivate and selecting this dot, right? I think that did it. All right, so we got it relocated. We have the spine. Now I want to create 8 surfaces. To be able to create surfaces, I need this line spelled out and this line spelled out. I want to go back to draft workbench and make this part of the sketch. I want to actually make it a line. So I want to open up the snap endpoint and say, so I just created a line there. I'll do the same thing on here. So take a line. While I'm at it, actually let's go ahead and make it all the way there. All 4 of these. I'll be using this line to create top and bottom surfaces. Okay, so we build this sketch so that I can get this line and this line from the sketches. So hide these 2 sketches. What I want to do, I want to make a surface following this extrude. So that would be another sweep. I take this line, which is the line first one, right? And then second line, and then take this sweep path as this continuous feature, right? I don't want to create a solid. I just say, okay, so it gives me the upper part of the spine. So we got this upper spine, but notice how these surfaces are broken down. And that is going to be actually a little inconvenient for us. Let me show you what I mean by that. So I want to take this sweep path and I do the same thing from here. So let's go ahead and take this line and this line, and then sweep path, I take this one undivided line as our path, and so this is one surface which has one edge on one side, another one, but this has like 4, 5 edges, and that's a minor inconvenience, and I would love to avoid that as much as I can. So that's why I actually all the time, whenever I can I build these lines. That helps me. But let's go ahead and keep working on it. Now what I want to do, so we got two surfaces of the spine, both upper and lower one. I want to select this edge and this edge and create a ruled surface. So we do the same thing for the end one. Because it's like it doesn't have any curves in anything, we can do that ruled surface. So select this edge and this edge and make a ruled surface. So now we have 4 surfaces. We have upper spine, lower spine, left ruled surface, and right ruled surface. All right, that was easy. Now we can create these side ones. So we'll have to go to surface workbench to do that. We will be using this filling part, and we add the edges sequentially. So here we click all the edges. This is where I say it's easier to have one edge. Just click one and then it just makes it easy. So there is another surface, and I can mirror that over on this part, or just while I'm here, keep adding these. All right, so I'm pressing the control keyboard from the keyboard and selecting these lines in sequence. All right, so we got the spine. So let's take a look at what we have so far. We have this spine, and then we have the sweep pad. Now we have the base pad, we have the cylinders. We're almost there. Only problem is this, that, and that. These are all solids. This is only surface, so we'll have to make it a solid. And one easy way to do that is select all the surfaces we just built. So that's 8 of them, and come here and then say make compound, and then take this compound and come to part, and here we can say convert to solid. Hide this compound. So we have the solid, and we can see if it is a solid. I learned this trick from Mango Jelly. We take a sphere from a primitive and make a cut, and if it cuts clean, that's a solid. So we have a pure solid built in here. Let's delete that cut, maybe keep that sphere for now. So we have spine, solid, and then we have these cylinders, and we have the base pad. Where is the base pad? Right here. Now we put all of these together to build our final object. I want to say these two goes first. Select this spine and then make a fusion, and then so uncut spine, right? And then I want to select this one and take the uncut spine and say come here and connect object. That removes the middle part and makes it a quick connect. Pretty awesome. I always love this tool. And we do the same thing. So take this one and take this cylinder and do another quick connect, and that is, I think, leftover from the line. There is another one, and that is our object. That is our object. Well, without the fillets, but the main thing is done. And let's see if we can apply the fillets. I won't have high hopes, but let's give it a try. We have R2 fillets all around, and so we select these lines and come here, select 2. Oh, it worked. Great. And we go back to that, actually keep adding these lines, see if it works. It worked. Is there anything else? I think that's it. Oh, there is a screw hole right here, and which it says from the 20 millimeter above from the baseline, and it says M10 through to bore. I'm gonna say this is M10, right? And then transform it to our need and bring it back a little bit. See if we can see that here. Okay, now all I want to do is take this one, and on the placement tab, on the position on the Z, I want to make it 20 millimeter above, so it's crossing, and I can make a cut. Okay, so I can make a cut. I can take the fillet and take the screw and come back to part workbench and make a cut. So that is our hole. It doesn't have any threads in it, but it's simple. So I'm going to say this is, and it's easy to actually make the thread. I go find that screw in the data tab, and I say thread is true. And it may take a minute, but it will create the threads. So here is this quick trick if you don't know it already. Before closing this document, always bring this thread back to false. So that way, when you open this file back up, it won't take long, because threads actually take some quite a lot of computing powers. So this, like, just keep it to no thread as default, but it's there. So I think we built the object. It took a while, but we finally did it. For the phase 2, I'll do that FEM analysis in our next part of this video. I hope you like this. If you have any question or any comment, please leave them below in the comment section.